Hey guys, I wanted to check in on two official chemistry topics, and I think the best way to, whoa, let me turn down my music for a second. I thought that my speakers were broken, but apparently they just needed time to wake up, much like most of us in the morning. Okay, so two things in this video. One is I want to make sure that I talk to you about the difference between a saturated hydrocarbon and an unsaturated hydrocarbon. And then the other thing is I want to show you how when like a double bond hydrocarbon splits open and can then add things to it. And so that's what you guys are reading about this week is addition reactions. So I want to give you some sort of visual with my nerdy models. And I wore my nerd shirt for you because we're talking chem. So, okay, so saturated versus unsaturated. So last week you guys made models with carbon and hydrogens and you maxed out all the bonds that carbons could possibly have on it. And so anywhere there was an opening, you put a hydrogen on there. This is called saturated. It's completely saturated with all the atoms that could possibly be on it. Okay, there's no double bonds, no moving of electrons to put them back together. So this is a saturated molecule. But if you have a double bond, like this molecule that you're going to be looking at in the pictures of the book that I have on that form this week, see this double bond here? So this is called ethene. It's a different naming scheme. So when you have only single bonds, those are called alkanes. So we call this ethane because there's two carbons. But when there's double bonds, we change the ending to ene. So this is an alkene. And because there's still two carbons, we still use that prefix eth. So it's ethene. Well, this double bond means that there was not, we're not maxed out on hydrogens here. So we're calling this unsaturated because we could put more hydrogens on there, more atoms, whatever. It doesn't have to be hydrogens if we wanted to. So this one is unsaturated. This one is saturated. And I have some pictures that I'll show you. I'll add these to the end of the video, but just kind of a explanation of some actual drawings on there. So obviously ask me questions if you want to get this down in your notes. Awesome. But it's on the book pages too. All right. So let's talk how this whole addition reaction thing works. Okay, so addition reactions are how polymers are made. So a polymer is something that is, not just two carbons long, it's hundreds of carbons long. How do they even do that? And so what the book talks about is having a double bond. And what happens is this double bond is really reactive. So we can really easily pop it open. It will just break open. And now it's available for something else to saturate it. And it'll only have single bonds. So if I had another double bond that also split open, now I can put them together. And so this ethene and this ethene now is turning into a longer alkane. And so you'll notice there's still spots here, right here, and right here, that more things could continue to get added onto. So if another one came along, then we could also add it, and so on and so on and so on, and you've got yourself a nice big long polymer chain. And so each one of these individual parts we call monomers. So here's a monomer, here's a monomer, and here's a monomer. So they all came in and made this polymer, right, for many. Your book also references dimers, and di means two. So when you just do the first two, like I had here, we call this a dimer. And that is an addition reaction. So that's really all the book is talking about, is how these double bonds are really extra reactive and they can split open. And when you have two double bonded things come together, so like if these ones are double bonded, they can split open and they will go and join up with each other because those double bonds are easy to break and pretty reactive. And so when two monomers, right, mono means one, when two monomers come together like this and their double bonds break open and they find each other, then now we have a dimer. And then once you get beyond that and you start to add more and more to your chain to make it longer, that's when you get a polymer, because poly means many. And so that's kind of the difference there. I also made a pretty fancy picture right here, just kind of trying to explain the process of how these, like how the double bond breaks open, and kind of now you have these points for attachment down here, and then these other ones come in. So I'm sure you guys have questions. Please check in with me, and I'll make sure to have pictures of these up on our Google Slides so you can check that. And I'm just looking at my book to make sure that there's nothing else. I think that's it. The only other thing that the book mentions is how so far we've had nothing but hydrocarbons. Well, sometimes there's not just hydrogens on here. There could be something else. Like sometimes there might be chlorines on there. And now we've completely kind of changed the properties of this monomer because this chlorine changes, you know, how dense the plastic is, how hard it's going to be, or brittle or soft. And so we could take a bunch of these with the chlorine on there and continue to add them and add them and add them and make a big long polymer. And you just have a chlorine every, you know, so often down the line. And that changes how the polymer works. So actually pretty cool how we've been able to like come up with this and make these different plastics for different purposes. Yeah, anyways, there is my Nerds Rule update for you on our polymer and organic chemistry. Let me know how it's going. Send questions my way, send feedback my way, and I will be in touch. Have a great day, guys. Bye.